welcome back to our YouTube channel Chakra of Knowledge. In the previous video, we studied the basics of electrostatics such as Coulomb's law, Gauss theorem, normal what is an electric charge, and the introductory part of the lesson electrostatics. In this video, we will be studying about the first three derivations that are in our book, which are electric field due to uniformly charged sphere, an infinite sheet, and an infinite rod. So moving on to our first derivation of Gauss law. The first application is finding electric field intensity due to uniformly charged spherical cell, or you can say sphere. So let's assume a sphere that is drawn in black color of radius capital R. The point is somewhere here, which is at a distance of small r from the concentric circle or point of the concentric sphere. Let's assume an imaginary Gaussian surface that is made with blue dots. So the point where we have to find the electric field intensity is basically on the edge, or you can say is on the outward point of our imaginary Gaussian surface at a distance of small r from our main sphere. The electric field works perpendicular to the radius, and let us assume a small area of circle, a small circular part, which we will call a ds. So as we know, electric flux, yesterday we studied the electric flux. As you remember from Gauss theorem, electric flux is equal to Q, that is total charge enclosed, upon epsilon naught. Let it be equation number 1. The other part we studied for electric flux is total flux is equal to integration over a closed loop into electric field dot area, that is ds vector. So if you want to write this, to remove the vector we will use E dot ds cos theta. Here the electric field is making an angle of 0 degree with the radius, or you can say the ds vector is making an angle of 0 degree with our electric field. As you can see here, it's 0 angle. So we can write this as phi is equal to E dot ds cos 0. What is the value of cos 0? The value of cos 0 is 1. So electric flux can be also written as E dot ds. So ds represents nothing but just the area of this circle, the one circle that's here. So what we can write is E into A of our circle. This is our equation number 2. Now we will be substituting the value of equation number 1 in equation number 2. So we will be getting electric flux is nothing but Q upon epsilon naught. So Q upon epsilon naught is equal to E into area of circle, area of sphere. So what is the area of this sphere? So area of sphere is generally 4 pi. And what is the radius of this sphere? Is it small r or capital R? Right, the area of sphere is capital R. So we will be taking here 4 pi r capital R square. What are we finding here in this question? We are finding electric field intensity. So we need E on the left side of the equation and rest all will be transferred on the right side. So E is equal to Q upon 4 pi epsilon naught R square into epsilon naught. We studied what is a surface charge density in our previous lecture. So, surface charge density is nothing else but, you know, the surface charge density. Here you are using sigma to denote surface charge density. So, surface charge density is Q, that is total charge enclosed, or we can write as total charge enclosed upon area of the surface that is enclosing. So here the area is this one, circle. So here we can write sigma into total charge is Q upon A. So we need to substitute it. Let us leave Q on this side and take A here. So Q is equal to sigma, let it be equation number 3. Q into sigma into A. Substituting this, let's make it equation 4. Now, substituting equation 4 in equation 3, what do we get? We get here E is nothing but Q is equal to sigma into A. So sigma into A upon 4 pi epsilon naught R square. What is the formula for A? This, the imaginary point, it's small r. So sigma into area of small sphere, that is 4 pi upon, what is the radius of this point? It's small r. So small r square upon 4 pi epsilon naught r square. Now what we can cancel from both the equations? We can cancel 4 pi here. So we will be cancelling 4 pi. What do we get now? Electric field is nothing but sigma r square upon epsilon naught r square. This is our first case. Here two more cases are there. The second case is, what if the point R is, instead of the point being here, the point which we are imagining as a closed Gaussian surface lies somewhere here. Let's suppose this is our case 2 and here this is R. So in case 2 we are getting this and this is equal. So we will be writing case 2 is the radius of sphere is equal to the radius of the imaginary Gaussian surface. So substituting this in the above equation, we will get E is equal to sigma r square upon epsilon naught. What is the value of this r? It's same as this r, so we will be putting it r square. Now we can cancel both the r. So the electric field intensity in the case when the Gaussian point is on the imaginary Gaussian surface is equal to the point on the sphere. So E will be equal to sigma, that is surface charge density, upon epsilon naught. This is our case 2. Then the case 3 is, suppose our small r is less than the r. So for case 3, let's imagine the point is somewhere here. As we know, the property of charge, that charge exists only on the surface of any object and not inside the object. Hence, in case 3, the electric field intensity becomes 0, because the charge does not exist inside the sphere. It only exists on the surface of the object or any particular shape you are taking. Hope so you are clear with the first derivation of our chapter. Intensity due to an infinitely long charged wire. तो बेसिकली जो हमने पहले किया था ये उससे डिफरेंट नहीं है, लगभग उसी की तरह है. सो नाउ हमने जो पहले लिखा था कि टोटल इलेक्ट्रिक फ्लक्स वो कितना होता है, वो होता है टोटल चार्ज एनक्लोज्ड अपॉन एप्सिलॉन नॉट. लेट इट बी इक्वेशन नंबर 1. अब एक और जो फॉर्मूला है हमें पता, वो टोटल इलेक्ट्रिक फ्लक्स का, वो है टोटल इलेक्ट्रिक फ्लक्स in an enclosed surface is nothing but E integration of E dot ds. ds यानी क्या, हमारा एरिया वेक्टर यानी एरिया. अब हमें जैसे कि पता है, अगर हमें वेक्टर फील्ड को स्केलर में कन्वर्ट करना है तो हमें cos थीटा लेना पड़ता है. तो हम E डॉट ds cos थीटा. जैसे कि आप देख सकते हैं जो ds है एंड इलेक्ट्रिक फील्ड है वो एक दूसरे से सेम डायरेक्शन में, यानी उनकी जो एंगल है वो है 0 डिग्री थीटा. सो यहाँ पे cos 0 आएगा, तो E डॉट ds cos 0. और cos 0 की वैल्यू हम सबको पता होती है, cos 0 1 होता है. Therefore हमारा इक्वेशन बनेगा E प्लस इज इक्वल टू E डॉट ds. ये हमारा इक्वेशन नंबर 2. अब लेट्स मूव ऑन टू समराइजिंग बोथ द इक्वेशंस. So after assessing both the equations we get Q upon epsilon naught is nothing but E dot area, that is area of the cylinder. तो सिलेंडर का एरिया क्या होता है, तो एरिया ऑफ सिलेंडर होता है, मेरे साथ एरिया ऑफ सिलेंडर होता है 2 पाई r इंटू h. तो यहाँ h क्या है, यहाँ h क्या है, h है l. तो h की जगह हम लिखेंगे 2 पाई r इंटू l. अब इसको हम ऊपर सब्स्टिट्यूट कर देंगे. तो सब्स्टिट्यूट करने के बाद हमें मिलता है Q अपॉन एप्सिलॉन नॉट इज नथिंग बट E इंटू 2 पाई r l. हम ढूंढ क्या रहे हैं, हम ढूंढ रहे हैं इलेक्ट्रिक फील्ड इंटेंसिटी, यानी हम E को ढूंढ रहे हैं. तो हम E को इसी साइड रह के बाकी सब वहां ले लेंगे. तो हमें मिलेगा Q अपॉन एप्सिलॉन नॉट इंटू 2 पाई r l. अब जैसे वो स्फीयर था तो हमने सरफेस चार्ज डेंसिटी निकाली थी. तो सरफेस चार्ज डेंसिटी, लीनियर सरफेस चार्ज डेंसिटी, क्योंकि यहाँ पे हाइट है, हाइट l. तो जो लीनियर चार्ज डेंसिटी होती है वो होती है लैम्बडा. उसको हम डिनोट करते हैं, उसे हम डिनोट करते हैं लैम्बडा से. तो लैम्बडा इज इक्वल टू टोटल चार्ज. टोटल चार्ज क्या होता है, Q अपॉन हाइट कितनी है इसकी, एल, तो हम इसको लिखेंगे एल। तो अब हमें Q की वैल्यू ढूंढनी है, तो Q इज इक्वल टू, ये इधर गया तो लैम्बडा इंटू एल। अब इसको हम सब्स्टिट्यूट करेंगे हमारे ये इक्वेशन नंबर 3 में, तो हमें क्या मिलेगा सब्स्टिट्यूट करने के बाद, हमें मिलेगा E इज इक्वल टू लैम्बडा एल अपॉन 2 पाई एप्सिलॉन नॉट आर एल। अब यहाँ पे जो कॉमन फैक्टर्स है वो कट हो जाएंगे, तो यहाँ पे कॉमन फैक्टर है एल, तो हम एल को कट कर देंगे, तो हमें मिलेगा E इज इक्वल टू लैम्बडा अपॉन 2 पाई एप्सिलॉन नॉट आर। ये हमारा फाइनल इक्वेशन है। Here we complete with our second derivation of the chapter. Hope so you understand this well. Make sure if you have any doubt regarding anything or any concepts in the video, you can directly comment and ask me out. I will be responding you within few hours. It will not take much time. Thank you so much for your valuable time. Hope so you may like, comment and subscribe our channel Chakra of Knowledge. Thank you. Meet you guys again tomorrow.